Welcome to another lesson on grade 9 mathematics. Today we will be reviewing the worksheet 1 on exponents. So exponents 1, question 1a says evaluate x to the power of 0. Now we know anything to the power of 0 equals 1. So the answer to this question is 1. Question B, true or false? Negative 3 squared or negative 3 squared. Are they the same or are they not the same? I would say that they are not equal, so this question is false. And I'll tell you why, because if we say negative 3 squared, that equals negative 9. So you have minus 9. But if you have the negative inside the brackets and you square it, a negative times a negative is a positive. So then you get positive 9. So they are not equal. Question C says, to simplify the following expression correctly, what must be done with the exponents? And our expression is 25 to the power of A, all to the power of B. So what happens to exponents when we're raising them to a power? We multiply. We multiply our exponents. We don't add them, we don't subtract them, we multiply. So the answer to this question is we multiply the exponents. Now let's just finish this equation. So we have 25a to the power of b, and this is 25ab. All right. So question 2a, we have 9x to the power of 4, y to the power of 5, all over 6x squared, y to the power of 10. Now remember what I said, when you take powers from the denominator into the numerator, you make them negative. Or what we could do is we could take out something that's common in both the numerator and the denominator. So I'm going to show you how to do this two ways. So we have a common 3x squared y 5, and then you're left with 3x squared on the top, all over 3x squared y 5, and you're left with 2y to the power 5 on the bottom. So then these two cancel, and you are left with 3x squared over 2y to the power of 5. Or we can write this as 3 over 2 x squared y to the negative 5. Another way that we can do this, instead of taking out something that's common, is we can say 9 divided by 6 will leave you with 3 over 2. And then you have x to the power of 4 minus 2 and y to the power of 5 minus 10. So you're left with 3 over 2, x to the power of 2, y to the power of negative 5. So as you can see, we get the same answer, but two different methods. All right, B, x to the power of 30, all over x to the power of negative 10. We can say x to the power of 30 plus 10, because when you take something from the denominator to the numerator, the sign changes. And this is x to the power of 40. C says 5x cubed y squared all to the power of 0. Anything to the power of 0 is 1. All right. So question D, we have a bracket that's raised to a power, which means our exponents get multiplied and our coefficient also gets multiplied. So we have 3 cubed is 27. M to the power of 1 times 3 is 3. And n to the power of 4 times 3 is 12. E is the same thing, except both of our variables have exponents. So we do the same thing. Negative 3 cubed is negative 9. X to the power of 4 times 3 is 12. And y to the power of 2 times 3 is 6. So with question F, we have b to the power of 5 times b to the power of 2. So when you're multiplying exponents, you add them. So we have b to the power of 5 plus 2, which is b to the power of 7. So G, we have the similar thing as in question F. Also, add the exponents when you multiply them. So we have b to the power of 4 plus 2, which is b to the power of 6. H, we have a fraction, so we want to get rid of the fraction. So we say in front of our x, this is a 1. So we have 1 over 8 x to the power of 10 minus 5, because this 5, when you bring it up to the numerator, becomes negative 5. So we have 1 over 8 x to the power of 5. Our variables are the same, so we can add our exponents. So if x to the power of 2 plus 4, which is x to the power of 6. Very similar to that question, except our variables are different letters of the alphabet. So J is 2r squared. So we have to square the coefficient as well, which means 2 squared is 4. R to the power of 1 times 2, which is 2. K, we also have a fraction, which means we need to get rid of our denominator. So we can say 32 divided by 8 is 4. A to the power of 4 minus 3, because when we bring this 3 up, it becomes a negative 3. And then b to the power of 2 minus 2. So we're left with 4, a to the power of 1, and b to the power of 0. Anything to the power of 0 is 1, which means it's just 4a. So question L, all of our bases are the same. They're all negative 2, which means all we need to do here is add the exponents, because you're multiplying. This dot means it's a times, so you're multiplying each one of these items in this expression. So we can still keep our base of negative 2. Then we're left with 3 plus 1 plus 2 plus 6, which leaves us with minus 2 to the power of 12. M, we have two fractions, which means we can take our denominators into our numerators. So we have a to the power of 1, b to the power of negative 2. That's this b, the b to the power of 2 that I'm bringing up to the numerator, times b to the power of 3, a to the power of minus 1, because we're also bringing this a up to the numerator. When you multiply, you add the exponents. So we have a to the power of 1 minus 1, b to the power of minus 2 plus 3. So we have a to the power of 0, b to the power of 1, which is a to the power of 0 is 1, so you're left with b. N, we have a bracket raised to a power. Whenever you're taking exponents and raising them to another power, you multiply them. So we have minus 4 squared, which leaves us with minus 16. M to the power of 2 times 2 is 4, and n to the power of 3 times 2 is 6. And O, anything raised to the power of 0 is equal to 1. So that whole expression is equal to 1. Lastly, we have P. Same thing, we have exponents raised to a power, so we multiply them. Minus 3 squared gives you minus 9. X 2 times 2 is 4, and y 5 times 2 is 10.